Welcome to Spring Lib.
In this exercise, we have two blocks, A and B, that are shown here in the figure. B rests on a table and has a mass of 2 kilograms, while block A is hanging from a cable and has a mass of 15 kilograms. And block A and B are connected by this green cable here. We give block B a speed of 10 meters per second, and our goal is to find what is the radius of the trajectory of block B around the table in its circular motion. So in order to find out, we need to first talk about circular motion. So let's briefly review it. All we need to know basically is that the acceleration associated with circular motion is equal to v squared divided by the radius of the trajectory, where v is the speed of the particle. So now we can proceed with the exercise. So what I'm going to do is to draw a free body diagram for both blocks. So first, for block A, we have the gravitational force acting downwards, ma times g, and we have the tension force from the cable acting upwards. For block B, we have the gravitational force, mbg, and the normal force from the surface of the table, but horizontally, we have the force of tension, which is the same as the tension experienced by A since the cable is the same. Now, in the vertical direction, the normal force is equal to mbg, so that the normal force balances out the gravitational force, since the block is not moving in the y direction, in the vertical direction. Now, in the horizontal direction, we have that the tension is the only force that acts on block B. So the tension must be equal to the mass of block B times v squared over r. So this is the mass times the acceleration. This is Newton's second law. Okay. And in order to find the tension, we can go back to block A. And since block A is hanging, then the tension must be equal to the mass times the acceleration of gravity, so that the tension balances the gravity. And we can now substitute it back into the equation for the circular motion of block B. So we have that ma times g is equal to mb times v squared over r. R then is equal to mb v squared over mag. And now we can substitute the numbers. mb is 2 kilograms, v is 10 meters per second, ma is 15 kilograms, while g is 9.8 meters per second squared. So r is equal to 1.36 meters, which concludes our exercise.